Okay, good, good. Okay, welcome to the live session. We have some questions which I will answer. And in the meantime, if any of you have got any questions, I will be happy to take that and respond to you first. And then we have a bunch of clarifications and questions. There was a claim that one of my question as well as the solution was wrong, but it is not wrong. The question was not properly understood. I will clarify those kind of things. Okay. I don't know in what manner these things are all communicated to all of you. There was one claim that one of the questions and their answers is wrong, and then and there was some publicly people were seeking, is it correct? Is this opinion and all? Have you gone through any of those things? Have you felt any such difficulty or any other difficulty that you have? You let me know. I'm happy to clarify and then help you people out. Okay. Anything that you have, let me know. Yeah, you should switch on your speaker and then talk. Or is it under our control? I don't know. So, Shekhar, Shankuri, are you able to follow everything in the class? Or you can type in the chat box. I don't know what is happening. Anything? Anything for Rahul Nandesh?
Sir, good evening.
Yeah, good evening. Tell me, please.
The assignment in week 4, the last 3 questions have 0 points.
Have they withdrawn that? Yeah, unless they have withdrawn that one, I don't think I have any. It has got only 0 points. That's ridiculous. I will check with them why there is 0 point. No, that I have given marks for everything. You got zero or
No,
there are
no.
no.
The answer is correct, but there it says 0 points. The above ones have 0.5 marks each, but the last 3 has only 0.
Wait a minute. I will get the secretary to clarify that point. She has gone to take a printout of something. She will be here in a minute. I will check with her. And then why 0 points are given? It should be. Any question that you answer, there is a credit for it and you should earn the credits. Okay. So that's one thing that I will immediately clarify once she arrives. She has just gone there to take a printout and I'll do that. Did you get a general note saying that one particular question was wrong in assignment 6 or something like that? People, anyone of you have noticed any such thing? If it is not, it's okay. I'm going to now address all queries. There are a lot of queries that are made, and for those queries, I need a printout. She has just gone there to take a printout. Once that comes, query by query, I will answer, and I will add to this. Why 0 point for uh, assignment for last questions? That's surprising.
Sir, and can you explain how to do the Johnson's reweighting? Because in theory, it wasn't that clear. If you were able to explain with few
Oh
examples.
yeah, sure, no problem. I'll do that. Johnson's. Wait, I will do that. I have to open a page. Page. Right? 1 second. participant. Yeah, I need to open, wait, I am going to explain that to you. I am waiting for the this one. There is something. Okay, here. See, the reweighting is done in the following manner. You can use any function and then do the reweighting as follows. W dash. This is the one before?
We will get that.
Okay. W dash UV equals WUV plus H of V minus H of V. For any H, this is well defined. This is a number. These are numbers because H is any function from vertex set to, let's say, integers. So add this integer and subtract that integer. You get another number. That is the new weight. What we are going to use for H is the shortest path weights. So we have a graph G. We have added another vertex S from which to every vertex of G with weight 0. Okay, with weight 0. Now you solve using Bellman and Ford. You can solve the single source shortest path problem with S as the source. Okay, and then solve the shortest. So for each vertex V, there is a delta V.
Sir, your screen is not seen.
Huh?
Your screen is not seen.
My voice is not clear?
No, your screen is not shared.
My screen is not shared. Wait. I've been writing something. It is coming here in the why the screen is not shared? It is
Sir, your video is sharing, but you write something, na? That is not shared.
Oh, okay. Yeah, my video is shared, but not what I am writing. Okay.
Yes, sir.
So I have to find out whatever the whatever I am writing is not getting shared to
One
people.
second.
Is it done? Okay. So are you able to see on the screen whatever I have
Yes.
done? Okay.
Yes, sir.
So this is the reweighting mechanism. This is the original weight. You can use any function H from vertex set. For each vertex, there is a number associated with this, defined like this. Now, what we are doing is, we are using for each V, delta V. What is delta V? From S to that vertex in G, the shortest path, weight of the shortest path. This number we are using. So, first solve the single source shortest path problem using Bellman and Ford algorithm. The Bellman and Ford algorithm is used because G may have positive and negative weights. Therefore, I must use Bellman and Ford algorithm to compute this one. When I use this for reweighting, that is W dash UV equal to WUV plus delta V minus delta U. If I use this, you see why we are using this. The reason is, you know that delta V is less than or equal to delta U plus W delta U plus W UV. So delta, sorry, yeah, H of V, I'm sorry. This V becomes minus. Sorry, this is not the reweighting. H of U minus H of. Doesn't matter. I'll tell you. So you move delta V there. 0 less than or equal to delta U minus delta V plus W UV. This number is always positive. So I am defining W dash UV. This is the new weight as old weight WUV plus delta U minus delta V. When I do like this, this is guaranteed to be positive. You can see that because of this inequality, this is always guaranteed to be positive. The reweighting is done just like this. So what is a reweighting algorithm? Find out delta U for all vertices. After finding delta U for all vertices, for every edge UV, for every edge UV is the eraser. For every edge UV, this is the reweighting formula. The reweighting guarantees you to get a new weight positive. So I have now a graph in which the weights are all positive. So now I can apply Dijkstra's algorithm. Dijkstra's algorithm can be applied only for the weights that are positive. I can apply Dijkstra's algorithm on reweighted graph. Okay. So I apply n times Dijkstra's algorithm. Therefore, the complexity is n times n times m plus n log n. And there is another nm. This is initial discovering the weight, reweighting. All of them will take this much cost. This is the complexity of applying n times the Dijkstra's algorithm. So all pair shortest path problem can be solved in nm plus n square log n time. Nm is observed here in big O notation. Therefore, the complexity is going to be the complexity is n times m plus n log n plus nm, but this nm is anyway here. Therefore, it is order nm plus n square log n. This is better than the n cube algorithm. You have Floyd-Warshall's algorithm. That is n cube. That algorithm is n cube. That algorithm is n cube for all graph. But this algorithm is n cube only for dense graph. This becomes order n cube when m is n square. That is for the dense graph. But when m is order n, sparse graph, suppose the graph has got much less number of edges, then this is n square plus n square log n. The dominant factor is n square log n. When this is the case, the complexity becomes order n square log n. Therefore, our algorithm is always better. This algorithm is always better than the Floyd-Warshall algorithm. Therefore, Johnson algorithm says first use Bellman and Ford, get the shortest path distances, use that to transform the weight or reweight and work on the same graph with respect to the reweighted graph. Then it will work. The book by Corman, that is the prescribed book, Corman, Introduction to Algorithm. Introduction to Algorithm. Third edition. This is available in Indian print. There is a fourth edition, but that fourth edition is available only in US print. That will be expensive. But third edition is available in Indian print, probably available for 600 or 700 rupees. It's a good book. You can buy that and keep them for your lifelong use. So anyway, this book has a section or a chapter on Johnson's algorithm. There everything what I have said will be available in print. A problem has been worked out, an example is given, all my discussions follow just that. So you can also see the example worked out over there. Okay, reweighting, computing the weight function, all of that you can see there. All right. Okay. So have I answered your question? Is it clear?
Sir, can you solve an example? The one which is in week 5.
No, that will take time because I have to compute everything, right? I have to apply the Bellman-Ford algorithm and then work out the whole detail. It's only the whole computation is completely worked out in Corman. You can see the whole thing is done in Corman. But if I work out here, it will take more than 45 minutes to do the details. That's the reason why I'm avoiding. But then it's just available. The whole thing with full detail is available in Corman. Don't worry, you can always. Or what I can do is I can write it and then post it later. What is this question? So let's go to the okay. This is not a complaint. We have they are asking that why for assignment 4
questions have been removed.
0.
Questions have been removed.
They have been removed. Okay. All right. So the answer why they have been given 0 is that those questions were removed. That's the reason. Okay. So even if you answer, it doesn't matter. Even if you don't answer, it is okay. Because they have probably it has come outside the week's coverage, or I don't know what has happened. But don't worry about those questions which have got 0 marks. But keep solving them for your own use, experience. Now, there is another major, what is this one? Kindly consider,
That's what.
yeah, there is a page.
Hello, sir.
Ah,
Am I
yeah.
audible?
Yes, yes.
Sir, could you please explain about forward edge, cross edge, tree edge, and back edge?
Yes, I can explain to you. Before that, let me first okay, what type of questions are expected in the exam? I will first answer that question. In the exam, we are going to ask question very similar to what is asked in the assignment. Straight from assignment, you are going to get some questions. And some questions will be twisted, changed from what is given in the assignment. That is how the exam, there will be some new questions. Okay, you have a percentage. 40% of the questions will be from assignment, and they will look pretty much like assignment, but with certain changes. That will be another 20 to 30%. Some 20% new questions. So it will be a mixture like that, but all questions are short questions and answers. Okay, that's how it will be. Very much like the assignment questions. So if you have worked out well on the assignment questions, you should not have any difficulty in dealing with the exam questions. Okay, so.
Sir, is it possible to get assignment questions?
Assignment questions?
Yes, sir. Derivation of assignment question. Actually, you are solving in a notation right now. Some answers are not getting. Like assignment 5, question number 3, you don't getting the cost 7 function like that.
No, no. What is what's your
Sir, my problem is You would explain in good way, but in problem solving, I have so much confusion. That's why you in assignment problems you get solved. We can clear understanding, sir.
Okay. No, first let us see what is forward edge, back edge, and other thing. Whatever is defined in the class is what you are asking as a question. Okay. So let's say this is the directed. Your screen is visible to you? I'm writing something. Okay.
Yes, sir.
Let us say 1, 2, 3, 4, 5, 6. Okay. These are, you start from 1. You go to 2. That is written like this. From 2, you can go to 4. From 4, you can go to 5. From 5, you can go to 6. From 6, you can't go anywhere. You backtrack. And then from 5, you can't go any further. 6 is the only option. That is when you go back to 4. From 4, you are going to 6. But then 6 is already visited. This is a forward edge. This is an example of forward edge. Forward edge means from ancestor to a descendant. Whenever an edge goes from the top to bottom. So this is going from 4 to 6.
4 to 6 is a forward edge, right?
4, 6 is a forward edge.
Okay.
4, 6 is a forward edge. Backward edge means it will go in the opposite direction. So let us see whether I get backward edge, otherwise I can draw. So at 4, you have the all options are over, go back to 2. When you go back to 2, there is no further option, go back to 1. From 1, you go to 3. And from 3, you are going to 4, but 4 is already visited. Okay. So this is an example of cross edge. Why this is a cross edge? It is not an ancestor. One is not the ancestor of the other. Ancestor means it should be above. There should be a chain. If there is a chain like this is ancestor, this is a descendant. Okay. One is a child of the another, another is a child of another. So if it is from ancestor to descendant, it is forward edge. If it is from descendant to ancestor, it is a back edge or backward edge. Why it is called the back edge? You are going in the opposite direction. You keep going like this. From here, let us say there is an edge like this. That is called the back edge. For example, if there is an edge like this, 1 to 4 is like this. There is a chain. But 4 to 1, you can see from descendant, it is going to an ancestor. This is an example of a back edge. So ancestor to descendant is forward edge. Descendant to ancestor is back edge. Suppose they are not ancestor or descendant like this. This one and this one, if you take, right, one is neither an ancestor nor a descendant, but they are connected by an edge. That is called the cross edge. So you have only 3 kinds of non-tree edges. Either descendant to ancestor, ancestor to descendant, or an edge connecting 2 vertices that are not related this way. Either they are related that way or not related that way. When they are not related that way, it's a cross edge. This is an example of cross edge. This 3, 4. This is 3. 3 is in one branch, 4 is in another branch. Therefore, that is an example of cross edge. So this figure gives you tree edge forward edge, backward edge, cross edge. All kinds of edges are given in this example. Okay.
Sir, what was asked was if you were able to share how the problems were solved in every assignment.
Which one is solved in every assignment problem?
Can you show the steps how you're solving each question in every assignment?
It is following the algorithm that is discussed in the class.
Sir, that in the class you're just explaining it theoretically, but you're not taking any particular examples and solving it, and few of us are having a difficulty.
Okay.
And when we ask for you, you say you can refer few textbooks, it's available other places, but that is not the point. We have paid for this course, so we would like you to share some material with us.
Okay. Good that you have, but then don't talk rudely like this because you have paid, somebody has to do the work and stuffs like that. That's not the right way. So the point is, if you want the online example of something to be worked out, it may take about 45 minutes to 50 minutes. That is the reason why I'm not saying here. But then I can work out an example and then I can post it. That's not a problem. That I will do. I'm not saying that I'm not going to work out an example for you. I can't work out that example because it's a take-home assignment. It will take about 30 minutes if I start working out the details over here. We don't have that much time. That's the reason why I said I'm not doing here. But I'll send you. No problem.
Yes, sir. I was asking if you could send us the method to solve it or the steps how it was solved.
Yeah.
Not able to explain it here.
No problem. We will do that. I will give you step-by-step working of the example. Of which example you want? You want the reweighting, right?
Sir, if possible, can you give it to all the assignment questions?
All the assignments. Okay. I'll see. What happened?
Hello, sir.
Huh.
Please. Go
Uh,
ahead.
Yeah, go ahead, go ahead.
Sir, I have a follow-up question on the ages that you have explained. The four kinds of ages.
Yes.
So with respect to sir, undirected graph, I mean, what kind of ages are possible? Because we know
Yes.
that in the directed graph, all kinds of ages are possible.
Right.
So
In undirected graph, there is only back edge because forward edge and backward edge are not going to be there. We don't have direction. They are one and the same, right? Whichever way you draw, therefore, you have only back edges. There won't be any cross edges. There won't be any cross edges in undirected graph. So let me write this. In undirected graph, okay, we do not have forward and backward edges, and they are merged to what is known as back edge. We do not have any cross edge. Cross edges are not at all possible. You don't have that kind of a direction. Always from wherever you are able to go in an undirected edge. Therefore, there won't be any cross edge. If some edge is not visited, it is going to be visited when it is due. So there is nothing like an edge that is not visited. You go to some other branch and from there you visit and other things. When you are in this branch itself, it would have been visited. So no cross edge. We don't distinguish between forward and backward because there are no directions. Therefore, we have only back edges. So I'll take an undirected graph and then suppose this is undirected 1, 2, 3, 4, 5, 6. Okay. So no directions. 5, 6. So you start from 4, let us say. From 4, you can go to either 1 or 3. Let us say you have gone to 3. From 3, you can go to 5. From 5, you can go to 6. Okay. From 6, 3. This is back edge. 3 is already visited. 6 is visited now. So it is back edge. So there is nothing to go from 6, nothing to go further from 5. At 3, now you visit 2. After coming to 3, you can visit 2. From 2, you can visit 1. Okay. And 1 now has got 1, 3. So 1, 3 is also, you can see, is the back edge. It's going from 1 to 3. Okay. So you can always see that from a descendant, you are going ahead, and therefore it will always be back edge. So you have only tree edge and back edge for undirected graph. In undirected graph, only tree edges and back edges. Okay.
Yes, sir. Sir, this is with respect to the DFS only, na? If we
Yes, only with respect to DFS.
yes, sir. If this graph, let's say, if we consider this graph and we perform the BFS on the this graph, then again
It will be completely different. In BFS, you don't have back edges. You have only cross edges. Tree
okay,
edges and all non-tree edges are cross edges
cross edges.
in undirected graph. Because you are going breadth first search, there is nothing for you to go back. It's a one-way flood, right? It goes like a flood into the front. Nothing goes back. Only cross. Non-tree edges will all be cross edges. So BFS has that property. We are not dealing with BFS in that depth. We have just seen only the basics of BFS, and that's because when we are able to solve almost everything with the DFS itself, so we didn't pay much attention to BFS. That's needed, and it is important if you are doing more advanced graph algorithms. But for the introductory graph algorithms, just knowing what BFS is enough. It's only DFS that you have to know because you are solving more advanced problem using DFS. Okay.
Okay, sir. Okay.
Yeah. Any other question?
Sir, with respect to that strongly connected components,
Yes.
I have a question.
Yes,
Let's say
please.
we have more than, let's say, one component in a graph, right?
Yeah.
And if we perform the DFS on a graph, let's say we found out one component,
Yeah.
and again we have to start the fresh DFS, right, on the new vertex.
Yeah.
So again we have to start with a new time. Let's say starting with 1, or where we have ended.
No. We are continuing the same DFS. The DFS is not complete unless all vertices are visited. Right?
Right.
So you may make fresh starting point. That means your DFS may result in a DFS forest.
Right.
For example, I will see 1, 2, 3, 4, and let us say 1, 2, 3, 4, 5, 6. Now you start from 1, you go to 2. From 2, you can go to 4. From 4, you can go to 3. From 3, you can go to 1, but that is back edge. Now everything related to 3 is over. You come back to 4. At 4, you don't have any more edges. There is no more outgoing edge. Therefore, you backtrack to 2. At 2 also, there is no more outgoing edge. You come to 1. No more outgoing edge. The visit you started from 1 has ended. But you have not visited all graph. There are still some unvisited vertices. So you start from one of the unvisited vertices. Let's say you start from 6. You start from 6, you go to 5. From 5, you go to 4, but 4 is already visited. Okay. And from 6, you are going to 4. That is also visited. So 6 to 5 is the only edge in the other component. Other things are cross edges. You make a fresh starting point from one of the unvisited vertices and try to visit as many as possible. If not all of them are visited, again, try to.
Yes, sir, but I was talking about the discovery time. So the discovery time of 6
It will
is,
continue.
it is going
It
to
will-
be 9, right? In
Yeah,
this-
yeah. It will be 9
Okay.
because that part is not touched at all until the node which you started with, right?
Yes, yes.
Until that is completed, until all vertices are visited, that discovery time is never touched. Therefore, for one, you get 1, 2, 3, 4, 5, 6, 7, 8. That will be done. The discovery time for 6 will be 9. You are right. The discovery time for 6 will be 9.
And so one more thing, let's say we have that you have explained, you have performed the DFS on the graph. We have and we have got 2 connected components, right?
Yes, in this example too.
So, sir, if again we need to perform the DFS on the reverse on the graph in order to check how many components are there.
Yes. The components algorithm is you reverse this, and on the reversed graph, for every vertex, you have a DFS number already computed.
Right.
In the reverse order of DFS, you perform another DFS.
Okay. So, sir, is there any relationship between the graph and the reverse of the graph in terms of the number of components? For example, in this graph, we got 2 components, right?
Yeah.
If we reverse the graph, can we say that we will get the same number of component as the graph G?
Yes. Same component and
Okay.
same number, everything will be same. That is because you have a path from U to V and V to U. By reversing the edges, what will happen is this path will become a path from U to V, and this path will become a path from V to U. Still you have a path from U to V and a path from V to U. So the definition of a strongly connected component is it is set of vertices in which you have paths from in both directions. When you reverse the edge, the same property holds good for the same set of vertices. Therefore, for G and G reverse, the strongly connected components are identical. They are one and the same. That is the reason why the strong component which you are outputting in the reverse is simply taken as an output for the original graph. That is because strong component of the reverse and strong component of the original graph are same. This is the argument why they are same. The definition is there must be a path from U to V and a path from V to U for every pair of vertices. That will be true even when you reverse all the edges.
Right, sir, right.
Okay. Except that the UV path will become VU path. VU path will become UV path. But still, between U and V, you have paths in both directions. That doesn't change. That is the reason why you have this scenario.
Yes, sir. Yes, sir. Thank you so much, sir.
Welcome.
And so
Any
one
other-
more question on DFS. There is
Yes,
something
please. Go ahead.
when you explain the algorithm about that coloring, I mean, in order to find out the ages and the DFS algorithm, there is something we have, I mean, there is a loop, for loop, and we are in for loop, you have written 1 to 2n in DFS.
Yes.
So why that 2n comes? Because you are visiting each vertex 2 times? one is one we visit the vertex when we discover the vertex.
And then once we exit.
Yes, that is why it is 2n, right?
Yes.
Okay, sir. Okay. So initially I got confused why 2n is
No, no,
coming.
2n comes because you are numbering each vertex once when you enter and then when you exit. It's only when you leave, you give the other number. In between, you may come back to that vertex several times. At the time, you don't touch that number. But when you exit, you make it into black and then put the number there. Therefore, you have only discovery time and finish time, V dot D and V dot F. Therefore, there are only 2n numbers you are using. That 1 to 2n because you are numbering consecutively. That's the reason why you have 1 to 2n.
Yes, sir. And can you please, sir, explain that condensed graph? I mean, we have find out these two components. So one is C1 and one is C2, right? In this example.
Yeah, in this example, is there an edge between any vertex here to any vertex here? There is no, right? Suppose this is C1, this is C2, this is C1, this is C2. This is the condensed graph. There is no edge going from C1 to C2 or from C2 to C1. The vertex in C1 and vertex in C2 are not connected
So
by
there,
any edge.
there is an edge from 5 to 4, no?
There is an edge from
5 to 4 in the graph, no?
yes.
So there should be an edge from C2 to C1, no?
No, no. What is C1? Oh, you are right. No, I thought 4, 5, 6 is the component. I am sorry. C1, you are right. C1 is 1, 2, 3, 4. 4 is included already. What a stupid thing I am doing. 1, 2, 3, 4 is C1. C2 is 5, 6. There is an edge from 6 to 4. There is an edge from 5 to 4. Therefore, there will be an edge from C2 to C1. Yeah, this is the condensed graph. You are
Okay.
right.
So, sir,
I'm sorry, I made a mistake. This
no issue, sir. Sir, and sir, if we reverse the graph and if we again we compute the condensed graph on the G reverse,
yeah,
then again in the condensed graph, the direction of the C, let's say here the direction from
yeah, the direction of the
is going to be
condensed
same,
graph will change,
right,
but
right.
not the directions with respect to the original graph,
Okay, sir. Okay.
right? Because you have reversed all edges, what will happen is this cycle, which is going like 1, 2, 3, 4, will go like 1, 3, 4, 2. It was going like this. Now it will go like this. That's all. Similarly, instead of 5, 6, it will go from 6, 5. That it will change. Therefore, these edges will change the direction. 4, 6, 4 will become 4, 6. 5, 4 will become 4, 5. So from C1, you will have edge coming too. But we are not going to build the condensed graphs for the reversed graph. We will consider condensed graph only for the original one. So, but your question, the answer for your question is the condensed graph will also be reversed.
Yes, yes. Okay. Understand, sir.
If you are looking at the condensed graph of the reversed graph. The components will be same. C1, C2, C3 will be same. In the original graph, you had edges going from C2 to C1. In the reverse graph, it will go from C1 to C2. Therefore, the condensed graph, if it is reversed, the edges will be reversed. That's okay.
Okay, sir. Okay. And one
Yeah.
more thing, let's say we have a graph in which we have only one component. We perform the DFS on a graph.
Yeah.
And all the vertices are there which are strongly connected.
Yes.
Then can we have a cycle in the condensed graph?
No, you are going to have only one vertex, isn't it?
Oh, okay.
The
Okay.
condensed graph will not have any
Yes, yes.
cycle. Condensed graph is a directed acyclic graph.
Yes, sir. Understand.
Yeah.
Sir, I want to say something about the assignment and the question. Sometimes what happens is in the
Yeah.
question some ambiguity is there.
Yeah, I
So
agree.
that is why we are getting confused. What is to be written in the, let's say,
I know.
NLP kind of questions.
Yes, I understand. This is the first time I'm teaching this online course. So much like you are attending, probably you are attending many other NPTEL courses, right?
No, sir, this is also my first time course.
For me, it is the first time. I was not expecting many of the problems that we have faced. In fact, had I asked as a multiple choice question, is the fourth edge deleted is, and then I give the edges. See what happens now is, where is the page?
Yes, sir. In that question, actually, I got confused.
No.
I
See,
thought that
typically,
I have to write the spanning tree, all the vertices that is form the spanning tree with fourth edge is deleted.
so the edges, some people write like this, A, B. Some people simply write like this. Some people write A, comma, B. Some people write like this, A, B. They are given like this. Some answers are like this.
Yes,
So,
sir. And in the
so
critical, we
in
can.
fact, if I had asked if AB is the answer, if I give AB, BA, CD, DA, like this, if I give, tick the correct answer, then you will tick this answer. You know that this is the answer, but when you write, different people write in different format. And when we say we are expecting this answer, we will tell the NPTEL admin that this is the answer. So what they put in the computer is that one. That computer, if it is not like A, comma B, it is awarding 0. So though your answer is correct, A, B, edge is correct, it doesn't understand because we tell the computer that only if there is a bracket A, comma B, another bracket, if it is there, you give mark, otherwise you don't give mark.
Yes, sir.
So there are different format of writing the answers.
And even let's say, sir, graph containing more than one edges with the same weight, then more than one minimum spanning tree is possible, right?
Yes.
So
Yeah.
So again, we have if we have written one answer, then again, let's say.
Yeah. That is the reason why we will always ask a question with distinct edge weights, so that you will have only one minimum spanning tree. And that minimum spanning tree is what we want. So we want the edges to be represented and so on. So in my final exam question paper, hopefully I will ask multiple choice and other things so that these kind of ambiguities do not arise.
Okay, sir. Okay. Thank you so much, sir.
Welcome.
And sir, one more thing. You have said there are 4 algorithms in order to compute the all-pair shortest path, right? One is a Johnson, one is a Floyd-Warshall algorithm. What are the other two's? Names are not given, right? In the that way.
Yeah, the names are not given. We have used the matrix multiplication and then found out all pair shortest path with n matrix multiplication, then log n multiplication by doubling, right? You compute W square, W power 4, and then so you have n power 4 algorithm, you have n cube log n algorithm, because one matrix multiplication is n cube. And when you double, you get log n multiplications only. And therefore, and in that context also, there was one question by somebody. How do you say d power 13 equal to d power 16? Why do you? And we are computing d power 13 by computing d power 16. Is d power 16 and d power 13 will be same? The answer is yes, because if you have the power, see, what is n minus 1? Number of edges less than or equal to n minus 1.
Right.
So dn minus 1 gives all pair shortest path. Therefore, even when you consider dn, it will be same as dn minus 1. And dn plus 1 is same as this, because dn plus 1 is not adding any more paths. All paths are considered here. Therefore, these are all same set. So, I take this advantage. Since I know that all larger values have the same value as the smaller one, computing d power 13 will be little complicated, but computing d power 0 to d1, d1 to d2, d2 to d4, d4 to d8, d8 to d16 is easy. Just square. Keep squaring the matrix and then you get it. Right? Therefore, I will compute d power 13 rather than d times d times d times d times. Rather than this way, I will compute this way. I'm computing d power 16, but d power 13 equal to d power 16. Therefore, this computation also gives the same answer, but that computation is simpler. That's the way we reason. Okay? So, these are the other matrix multiplication algorithms. The shortest path distance algorithm.
Okay, sir. Okay. And
Very
sir,
good. Yeah.
in assignment 6, there are some questions regarding the DFS.
Hmm.
So actually, the order in which we have to visit the vertices is given. Let's say 1, 2, 3.
Yes, that's right. Otherwise, there will be different DFS trees. Yeah.
Yes, sir. So, let's say we perform the DFS, right? And out of, let's say, 1, 2, 3, 4, 5, 6, we have got 3 vertices in one DFS forest.
Hmm.
So again, we have to start with the second one, or from where we have.
No, among the unvisited vertex, how to choose? The policy is given there. Among the unvisited one, choose the smallest. So if 3, 7, 9 are not visited, start from 3.
Okay, okay.
Among the unvisited vertex, start from the minimum one. That's all it's like. Okay. You can start from anywhere, but in order to have some strategy, a well-defined strategy, I gave the starting point for fresh search continuation. That's it.
Okay, so understood, sir. Thank you so much.
Welcome. Okay. So all questions are answered. They have. The notations and proofs used in lecture way more theoretical, whereas the assignment questions were more practical. The question is, will there be any questions in the exam related to proofs and notations, or will the questions be related to understanding of the concepts and practical applications? The questions in the exam will be related to understanding of the concepts. If possible, provide solution to question number assignment 6, question number 2, and secondly, what will be your advice before certification exam? Should we follow any other resource? There is, first of all, I will provide the solution for this, and you don't have to really go through any other material than what is discussed in the class, and just follow the pattern that is given in the assignment. That is good enough. In all discussions, you will see that the theoretical discussions and explanations will be given so that you understand the concepts and principles. If I ask you to write an algorithm and its analysis and other things, it could become very difficult. So the way to evaluate is ask the students whether I understood the algorithm. Do you know how to implement that every step? So we check various things, execute this algorithm. That algorithm is going to reject some edges and accept some edges. Only when you go through that algorithm execution carefully, all edges rejected will be identified. In that process, which is the 4th edge that is rejected. So you have to go through that computation and then have all the information, then answer the questions. What is the 3rd edge included? What is the 4th edge deleted? All these kind of questions will be there, and it is just the execution of the algorithm.
Are there any more questions?
Okay, we will answer all of them. Okay, we'll do that. All the best, and do not have any fear or any mental stress. This is an exam in which your basic understanding will be tested. So, just your experience in your assignments are good enough. All exam questions will either be from the assignment or will resemble the assignment questions. So you will not have anything that is strange, confusing, and other things. The things may come because of some typographical error and that kind of a confusion. We are trying to eliminate as many of them as possible, but still, if there are any, we will deal with that when we get to know those kind of problems. Okay.
Okay, sir. Thank you.
Thank you very much. Thanks and
Uh,
all the best.
Okay, sir. Sir, better to provide solution. It is useful for me.
I will do that. I'll
Okay,
do that. Definitely, I'll do that.
Okay, sir.
Thank you.
Thank you, sir.